Hi, I'm Megan Hellier, and today I'm going to be talking about one of my favorite subjects in physics and engineering.
Dr. Adrian Bajan first proposed this theory in 1994, after making connections between the visual aspect of the natural world and the math of physics. His law is incredible and unique because it applies to so much in our daily lives. It applies to evolution design, so us as humans, as well as constructal thermodynamics, which I'll go more into detail on later in the video. So in the constructal law, there are three main rules and steps towards making this design in nature, which is number one, flow. Flow systems or objects are ones which structure have a temporary state created by flowing streams of energy or material information. In the case of humans, you could use the example of our blood flowing through our veins, or nature's lightning, electricity, flowing through the easiest path to the ground. Number two is design generation and evolution. This phenomenon is essentially each iteration of flow to the exponentially increasing x power of time, during which the design continues branching outward from the bigger part of it or to the main stem into smaller and smaller branches. Ultimately, it takes the easiest path of flow. This picture of a river illustrates how this takes place, rather than it just forming equally as large streams. And finally, the third principle is that there is a universal tendency for evolution in time. Since this is also biology's first law, this basically means that as time goes on, finite systems will branch outward and continue evolving to the easiest path of flow, not inversely or forming bigger paths. These diagrams show examples. You have a human body, the Pokemon chart, and human evolution as a whole. So how has the discovery of this law impacted physics? Ultimately, constructal thermodynamics has served to give a better and more in-depth description of normal thermodynamics. General thermodynamics is based on two principles, which is conservation of energy and energy flow from high to low systems. It's a very general, but with constructal theory providing a better illustration for scientists on how these systems flow more and more easily over time, it makes it possible to easily predict and then test through experiments how many designs and systems will evolve. The factors which it can predict can have many applications, such as traffic and the development of new roadways, river basins, as I've already shown, our lungs and circulatory systems for the development of new medical technologies. And that's my summary of the constructal law.